So, hello and welcome in this today's webcast where Ferrovia, CGS Plus railway design software solution will be presented. My name is Leon Leban and I'll guide you through this general overview of the Ferrovia functionalities. Let's start from the availability of Ferrovia. So it comes in three different packages: in Ferrovia Standard, Ferrovia Professional 3D, and Ferrovia Ultimate 4D software packages, which differ based on the functionalities and also the cost of those packages. As seen, the standard package has basically everything a railway designer needs to create any kind of rail track projects. But the professional 3D adds additional, let's say, tools to make that work even faster and easier, also more complex. So it includes also rail connection tools, the 3D solids creation, and there are some specific maintenance tools for the rail track realignment calculation. Whereas the Ferrovia Ultimate 4D, it includes all the BIM functionality needed, but also a special software tool for clearance envelope analysis. So, and that one comes from AutoTURN Rail 3D software solution, which is not CGS, developed by CGS, but we have included it in the Ferrovia package. So it's a very convenient way of how to use that kind of functionality on top of Ferrovia. Okay, so those packages are also very, let's say, efficient when needed more licenses. So users can combine some ultimate, more professional, and some standard packages in order to, let's say, to adjust to their workflow, to their organization, and the stuff they are using for the design. Okay, so Ferrovia software. It works on top of Autodesk platforms, so AutoCAD and Civil 3D, as well as on top of BricsCAD, which is a very cost-effective CAD platform, and it works in some cases even faster on that one for any reasons. What's important is that multiple versions of those CAD platforms are supported. So on the AutoCAD side, from the latest 2016 all the way down to 2011. So basically, the latest Ferrovia 2016 version can be installed on an old AutoCAD down to 2011. So basically, users are able to use all the latest technology for the railway design on some previous versions of AutoCAD, in case they haven't upgraded it. The same goes also on the Brics side, so versions from 15 down to 13 are supported. Then we'll just start, let's say, with some videos and with some new stuff which was added to the Ferrovia functionality, and then we'll go more in details. So a very important thing is a 3D solid creation tool, which enables to create railway models, bridges, tunnels, present them in very nice visual way in 3D in drawings. It allows also to make 4D analysis later on to make some visual checks within the drawing, but also to export those 3D solids to other softwares, which maybe you yourself or some other team is using. Let's say a bridges design team or some other departments which need railway designed model to have for their own work. Okay, we will show you in a short video how very simple and very efficiently tunnel can be represented with the use of this 3D solid technology. So what we need, let's go through this video. What we need here is an alignment profile and cross sections defined. And you can see in the bottom right picture, there's also a tunnel section, which is basically created by inserting a block that was defined by user. So when that kind of block is inserted, what's needed to be done is just to calculate all those areas with the functionality, and you can see now in the 3D on the left, so that the rail track has been already created, but also the tunnel section, and there's also a bridge which have been created directly out of the cross sections that were defined. Okay, so here's a bridge section, and you can see, so now the 3D model is based per sections, which are 50 meters away, so it's not very accurate, but the tool allows to basically to adjust that 3D solid based on the curvature of the alignment. So in the curve section, you can see now also here the tunnel. Now everything is aligned according to the curvature of the track. So what we'll put here is just a 3D rail scene, 3D view of the rail scene, and then just move along those and see. So that kind of visualizations can be done really very fast and very efficiently. Okay, so let's move on. One thing that would like to emphasize is that Ferrovia comes in different languages, but also in different, so it supports different country standards. Especially, let's say here in the Eastern European side, basically every country has its own all details, but also larger countries worldwide, they have some specialties. And Ferrovia, so CGS implements in the Ferrovia localized standards, whereas if in case some of them are not in there, users are still able to add those values by themselves. So Ferrovia integrates also a surface modeling tool. So that's needed when running on BricsCAD, which doesn't have the DTM modeling tool or the plain AutoCAD. So Ferrovia comes with a quite powerful digital rail modeling. Then what Ferrovia has is plenty of alignment design methods. So the free and floating alignment design method, the fixed elements design, the PI-based design by just drawing tangent polygon. Then it supports parallel rail track design. It can, of course, also convert polylines to alignment. And there's a special feature, so the regression method. So based on the surveyed points of the existing rail track, an alignment can be recreated. What Ferrovia has, of course, is also the applied Cant calculation. And this Cant calculation can be made by using an applied Cant table, which is basically standard values defined country per country, or it can be calculated based on the calculation parameters. So there's a typical standard formula used worldwide. There are just parameters that are different, so users can also change those parameters and get the proper applied Cant values. It also supports the rotation point of the Cant, so inside rail, outside rail, or center line. And what it also gets in is the Cant editor, where based on the geometry of the rail track and the speed, the applied Cant has been calculated, and then user can check the Cant efficiency, run-off grade, raising speed, lateral acceleration, and then change all the values accordingly to be within the allowed values. What Ferrovia has also, it's a multiple transition curve support, so it supports linear and non-linear transition curves. On the linear side, there's plenty of cubic parabolas, which are different for various reasons in different countries. But it also uses, it supports non-linear transition curves, not only on the alignment, but also on the on this applied runoffs as well. Then there is a multiple design speed definition. So along the alignment, multiple design speed can be defined on the alignment, but they are also dependent whether, so if we move slightly back to this Cant editor, if for some reason in one curve a speed has been changed, that change of the speed also refers to the alignment in this design speed dialog. There are different gauges supported. So as alongside the normal one, there are also the narrower and wider gauges supported in Ferrovia. There's a station equation function. So basically, when there's a jump in station for, let's say, for some reasons that maybe some rail track, one part of rail track was reconstructed, and there's so we would like to keep all the existing stationing prior to that section and after that section. So all those station jumps can be set in this station equation dialog. There's quite powerful turnout design tools available. In the draw turnout dialog box, so there are different turnout types supported. So from normal one that can be placed in tangent, there are the curved, so that the normal turnouts that can be placed in curve, and as seen in the picture below, so the transformation of the turnouts is done automatically. So the branched alignment radius is calculated based on the radius of the main alignment. So that's basically automatically created, and users able to design the branched alignment from the turnout on. There's symmetrical turnouts in and crossings, so all those are supported. If in case there is not available any geometry that user needs, there's also a turnout catalog where users can define their own parameters for the turnouts and add them to the library list. Then there is also this the Turnout rail connection tool. So for connecting the two rail tracks with the two turnouts and a small part of the alignments in between them. And there are different methods of how to do that. So this tool supports to create those rail connections not only between the parallel rail tracks in tangent, which is let's say quite an easy example, but it supports also creation of those rail connections in between non-parallel rail tracks, either in tangent section and in curve section. This tool also supports possibility to use different types of switches. So let's say, as in this example, so on one rail track there was a switch with the radius 500, and on the other one the switch with the radius 300. So there's also in the alignment part in between those turnouts that needs to be adjusted with the proper radius and some parameters, and everything is available within this dialog box, and also enables users to add all needed values. So let's just move to this video. So here we'll just see, so here are the different turnout types. We'll place a symmetrical one on the beginning of the alignment. So the two new branched alignment have been created. We'll also place one on the back, on the end of this alignment, like that. So all the branched alignments are calculated automatically. We'll also put a crossing one, so in tangent or in curve. Everything is done basically on the fly. Here's an example when a rail connection was done between two rail tracks, and we just need to put one crossings in between on the middle rail track. So we'll in this case use the existing alignment. Then we'll just move to another example. In this case, the turnouts are of the same types, and when we change them to different types, we then need to adjust those the part of the alignment in between those turnouts. Okay, a preview is always available when moving along the alignment, so user sees where that rail connection can be done. There are also some areas where this rail connection cannot be done, especially between spirals. Okay, so let's move on. There's a profile design where we would like to emphasize just a few things. So there's a possibility to superimpose profiles of other rail tracks left or right from this main track that we are, let's say, working on. So we can have multiple profile projections in the profile view. We can also project horizontal elements, so from layout to the profile, so any kind of elements, signals, turnouts, walls, whatever. There are some special tools for rail track realignment calculations, so in order to get the difference between the existing rail track elevations and the designed one. And all the changes, of course, are also always dynamically updated. There are two different ways of how to design a rail track. Let's say the simple one, especially for some preliminary designs, based on alignment and profile design using grading. So basically, just in three steps, user is able to create 3D models of the rail track, and then all the editing of the geometry is then updated with all the cut and fills updated as well. So let's see this example in a video. So what we have here is, so basically what we have is a digital terrain model on top of which we are designing an alignment. We then projected this alignment to the digital terrain model. We'll create a profile. So now it's a profile view. Okay, the calculation of Cant was done. Everything is in the profile view bands. So now the profile gets drawn. Okay. And then what user does is just updates the layout, and the 3D rail track is already done, already created. So we'll just change the view. So here is the position of the rails included with the applied Cant, which was calculated, and user is just now will define so the left rail and the right rail, from where a grading based on some, let's say, parameters will be now created. So we are in this example using just a fill grading, just for the matter of example. So it creates all the grading, the daylight gradings. Okay. So that's a short and a very easy way of how to get a 3D model of a new rail track which user is designing, and then all the volumes calculation can be created directly from that grading. Whereas later on, where user, let's say, continues with that preliminary design, so it moves on and needs more detailed cross-section design. So with the drawing of the cross-section views, user has the possibility to set all the cross-section view geometry in detail. So the grading might be more, let's say, generic definition of that cross-section, whereas here in the cross-section a very detailed design with, you can also see with all the platforms and everything which is needed can be created. Also, Ferrovia supports multiple rail tracks to be represented in a single cross-section view, and also roads, which were done with Platea, another CGS software solution for roadway design. There's also a macro definition, so user just needs to set the cross-section geometry once, save it to a macro, and next time just runs it, and the cross-section is reproduced in a matter of seconds. So then a very detailed 3D corridors can be created, even with a much more greater, let's say, accuracy of the volumes as well. Speaking of volumes, Ferrovia supports the QTO calculation, and in order to support all the BIM functionality, so all the QTOs, all the quantity takeoffs, all the materials that are defined and listed, they can be to those as special ID can be added or assigned, which is then used in basically any kind of software user are using for the cost analysis. So those softwares, usually they use some IDs for the materials, and just by linking the same IDs to the quantities defined in Ferrovia that export to any kind of software user uses is done basically digitally with no copy pasting, just linking it with the proper codes. As shown before, in order to create those 3D solids that were presented in the first video, what user needs to do is basically on top of the geometry that was set, just define all the materials, and those materials are then used to create the 3D solids that we have seen. There's plenty of import and export possibilities for the data. So in Ferrovia there's a LandXML interface, so that user can export all the data to a LandXML data format. There's also a function that converts civil 3D alignments and profiles to Ferrovia alignments and profiles, and vice versa. So basically, if user gets some drawing that was designed in civil 3D, it can convert just with a click the alignment and profile to Ferrovia alignment and profile, and then continue with all the detailed work that it needs. All the data can be exported to InfraWorks, also to Google Earth, and there are some other interfaces available. Ferrovia also comes with specialized solutions for the rail track realignments. So basically, based on existing rail track surveyed points, a new alignment with the best fit method has been created, also the profile, and then all those heights difference and also the offsets of the rail track, of the existing rail track, are automatically calculated, and that data is then saved in the format which this specialized stamping machinery uses. So the data goes directly in the computer that's on this machinery, and then the realignment works is done automatically. Here's just an example of this machine in work. Okay, so at the end, just touching the AutoTURN Rail 3D, so there's a clearance analysis tool as well, which is very useful in order to check whether all the vehicles, the rail vehicles, will go, let's say, through some tunnel sections, through some bridges, but also to check all the clearances to the left and to the right, let's say, in order to define whether all the signals are at the right offset and all the masts and all the elements alongside the rail track. So there are different clearances that can be defined, and what the software enables is also a 3D view of all those clearances, of all those envelopes, where in this example it's additionally shown also there's a part of tunnel that was created, a part of a platform, so user can visually now check, but also then create the cross-section views to see all the differences, the offsets of the elements. What's also important here with the blue line, the pantograph is also visualized, so we can check the height of that pantograph, but also the red lines define the points where the doors open, and that's always important. So let's say in this example, so there's a door in the middle of this rail vehicle, and you can see that the offset to the platform is very big, and it's not really handy. It can be used for any kind, for heavy rail, for light rail, and all the other projects that are done with the Ferrovia. And just to finish, I'd just like to touch some Ferrovia references which have been created up to now. There's a broad worldwide reference of companies. Some of them are listed here, and just two projects are here to, let's say, which are maybe the most interesting ones. So one is has been done in Saudi Arabia. There was a completely new rail track created between the Daman and Jubail. And there's another project which was created in Turkey. This one was extremely long, so it was almost 400 kilometers long, and it was all done within the Ferrovia, which basically enabled that kind of long projects within the same drawing that the customers needed to do, and all the cross sections on basically every 10 meters, because they wanted to have very detailed calculations of all the materials needed for the reconstruction of the existing rail track, which was placed in a very, let's say, very demanding conditions. Okay, so just before we finish, I'd just like to remind you that Ferrovia comes in different packages based on the user needs. So if you're interested for more, we would invite you to contact us through our webpage. So go to cgsplus.com, go to Ferrovia webpage, and there's an inquiry form. Just fill in all your data, and we'll get in touch with you with more information, videos, and also prices, whatever needed. So thank you for today, and looking forward for some other time. Goodbye.